Now it is time to check if you understood the concepts discussed so far by answering these questions. The graph of position against time of a car moving with uniform velocity is a straight line. That is a concept we discussed. If a car is accelerating, what will be the graph of position against time look like? Well, I have three graphs here. Graph B is a straight line. What does that tell you about the acceleration of car B? What does the graph of car A tell you about its acceleration? And how about the acceleration of car C? Now, in the graph of position versus time for three cars A, B, and C, that is shown here, how does the acceleration of A compare to that of C? Write a sentence about it. How does the acceleration of B compare to that of C? How does the acceleration of B compare to that of A? In other words, you write three sentences comparing the acceleration of these three cars, comparing the acceleration of one with respect to the other. All right? If you want the answers, continue watching. Well, since the graph of B is a straight line, it has a constant slope. It means the velocity is a constant. If the velocity is a constant, it means there is no acceleration. That means car B is moving with uniform velocity. The slope of that graph will be that uniform velocity. Since the velocity is uniform, there is no acceleration. All right? Graphs of A and C, you can see, are curving up. What does it mean when the graph of position against time of a moving object is curving up? If the graph of position against time curves up, it means the object has positive acceleration. So A and C have positive acceleration, whereas B has no acceleration. Since graph of A curves up more than the graph of C, A has greater positive acceleration. That means car A has a greater positive acceleration than